Hi everybody, the channel Easy Lecture welcomes you. In this video we are going to discuss the concepts of inverting amplifier. Yes, inverting amplifier is a very simple concept, but in addition to that, in this video I am going to explain the concept related to virtually grounded and why a particular node in an inverting amplifier takes the voltage that is given to the non-inverting input terminal. Okay, so that is related to virtually grounded. So this video is going to be very informative and very useful. Watch the complete video and get the benefit of it, and don't forget to subscribe my channel. Now let us enter into further discussion. This circuit shows the inverting amplifier, how operational amplifier is used as an inverting amplifier. So we are giving the input voltage to the inverting terminal and non-inverting terminal is grounded. There is a feedback loop connected from the output to the inverting terminal, input inverting terminal. So this is the thing, and we have in the feedback loop we have the feedback resistance, and the input voltage is connected to the input inverting terminal of operational amplifier to the resistance Rin. So this is the structure of inverting amplifier circuit. So from the circuit, let us first derive the gain of this inverting amplifier. Vin is there, that means the electromotive force is there. This electromotive force drives the electrons to flow. As a result, there is a flow of current. Current is generated. Flow of current in this circuit across this resistance Rin. Okay, but what happens? This current, it does not enter into this operational amplifier. The reason is, for an operational amplifier, the characteristics of operational amplifier, according to it, the input impedance is infinity. Okay, so since for an ideal operational amplifier, the input impedance is infinity. Since the input impedance is infinity, for a practical amplifier, the input impedance is going to be very high. It takes a very high value. As a result, it does not allow the current to enter into the operation amplifier. So this is the thing. So what happens? All the current which is generated by this, which is derived by this Vin, the entire current flows through the feedback loop. Okay, so the name we give for the current that is generated, that is derived by this input voltage is Vin, and the name for the current flowing through the feedback loop is taking the name as If. Okay, so from this concept we can make that input current is equal to the feedback current. Okay, In is equal to If. Now we are going to apply Kirchhoff's law. So Kirchhoff's law, so In is Vin minus Va divided by Rin, and If is Va minus V out divided by Rf. So that is what I am writing here. Vin minus Va divided by Rin equal to Va minus V out divided by Rf. This is by applying Kirchhoff's current law. Okay. Now the value of Va is 0. Okay. The value of Va is 0. The reason is the node A. So this is the node A. This node A is virtually grounded with respect to this non-inverting input terminal. So this node A will take the voltage value same as that of the voltage that is available in the non-inverting input terminal. So we call, the reason is this node A is virtually grounded. Okay. So I will explain the concept of that virtually grounded after completing this explanation. Okay, so here the voltage of non-inverting input terminal is 0. So this is 0. Since this is 0, the voltage at node A, Va, is also equal to 0. And when we apply the value Va equal to 0, here the equation becomes Vin by Rin equal to minus V out divided by Rf. Upon rearranging this, we will be getting V out divided by V in is equal to minus RF divided by Rin. This minus RF divided by Rin is the gain of inverting amplifier, and there is a negative sign here. The gain of the operational amplifier has a negative sign, so which indicates that it is out of phase. The output voltage is out of phase by 180 degree compared to the input voltage. Okay, and it is amplified. The output voltage is amplified by the amplification factor of RF divided by Rin. So since the the magnitude of the gain is RF divided by Rin. Okay, so what happens diagrammatically, if we represent, if this is the input voltage, the output voltage is phase shifted by 180 degree, and also it is amplified by a factor of RF divided by Rin. So this is the thing. Okay, so this is regarding inverting amplifier, all about inverting amplifier. But here I need to explain the concept of virtual ground. Okay, now again let us recall the characteristics of ideal operation amplifier. The ideal operation amplifier has the gain of infinity. So gain of an operational amplifier is infinity. Okay, so this is one thing. Okay, then what is the purpose of operational amplifier? What is the action being done by operational amplifier? Operational amplifier, it does not amplify any voltage, but it amplifies the difference of voltage between the two input terminals. We have two input terminals for an operational amplifier, inverting input terminal and non-inverting input terminal. The voltages applied to these input terminals, the difference is taken and the difference is amplified, and that is available in the output of operational amplifier. That is the thing. Okay, so it amplifies the difference, not the actual input voltage. So this is the thing, right? Now what happens, since the gain is infinity, the output voltage given by the operation amplifier is V out is equal to this infinity into the difference between the two input terminals. Okay, VD. Okay, so obviously V out becomes infinity. So this is for an ideal operational amplifier. Let us consider a practical operational amplifier. So practical operational amplifier does not take the value of gain as infinity. Instead, it takes the gain as a very high value in the range of 10 power 5 or 10 power 6. In that range, it takes the value 10 power 5 or 10 power 6. Okay, so even then, what happens, even if the difference between the difference of voltages between the two input terminals is very minute, very small, then also the amplification, since the gain is very high, the amplification is done in a very greater range. The output voltage, that is why it is forced to enter into saturation region in order to being operated in the linear region. Okay, so that is the greatest disadvantages of operational amplifier. This happens when we make the operational amplifier to operate in open loop configuration, and that is why we are making a feedback loop, and we are providing some portion of the output to be available in the to the input terminal. So this concept is called as closed loop configuration. Only after identifying the closed loop configuration, the operational amplifiers are used in many applications. Okay, so this is the thing. Now coming back here, so I have explained the difference between the understanding of closed loop configuration and open loop configuration in another video. Okay, now coming back to this point, what happens, let us view this thing, the infinity gain in another angle, or high gain in another angle. Suppose I need an output voltage of V out, output voltage of 1 volt. Okay, so let V out equal to 1 volt. This is what I require. Okay, this is the requirement. So what happens, let the gain be 10 power 6. Okay, so what should be the difference between the two input voltages? If V out is equal to 1 volt and the gain is 10 power 6, that means in the megavolt range. So V out is equal to this gain 10 power 6 into difference between two input voltages, V1 minus V2. Okay, let V1 be the input voltage of non-inverting terminal and V2 be the input voltage of inverting terminal. So this is the thing. Okay, so what will be V1 minus V2 from this equation? V1 minus V2 equal to the value of V0 is 1 volt. Okay, so when we take this 10 power 6 to the left hand side, it becomes 1 divided by 10 power 6, so that is equal to 10 power minus 6 volt. Okay, so that means the difference between the two voltages V1 and V2 is equal to 10 power minus 6. So which is a very small value, very minute value. It is in the microvolt range. So this operational amplifier is able to amplify this microvolt range and give a useful output in the linear region. Okay, and when we analyze this difference, this microvolt, it is a very small volt, so we can approximate this to 0 volt. V1 minus V2 is approximately equal to 0. Okay, that means V1 is equal to V2. V1 is approximately equal to V2. Okay, so whatever the voltage that is available in non-inverting input terminal, the same voltage is available in the inverting input terminal. So this is the thing, and that is why we say that V2 is virtually grounded with respect to V1. And here in inverting terminal analysis, the circuit analysis we have done so far, this point, this node A, it is virtually grounded with respect to the non-inverting input terminal, and the non-inverting input terminal is grounded. It is not virtually grounded, it is actually grounded, and so it takes the value of V1 equal to 0. Since V1 equal to 0, the voltage at node A, VA, is also equal to 0, since it is virtually grounded with respect to the non-inverting input voltage. Okay, V1. Okay, so that is why we are having this kind of again this kind of derivations. So I hope you understand what is meant by inverting amplifier and the concepts related with virtually ground. And here we have applied the characteristics of operational amplifier, both ideal operational amplifier, and we have utilized the concepts related with the characteristics of practical operational amplifier, and we have analyzed these things, and we have derived the gain of operational amplifier. I hope this video will be very useful to you in understanding the basic things related to inverting amplifier. Of course, inverting amplifier is a basic concept related with the applications of operational amplifier, but many doubts related with virtually grounded can be overcome by viewing this video. So this is my hope. Thank you for watching this video. Meet you again in another video. So don't forget to subscribe my channel Easy Lecture. Until then, bye.